Hi everyone! In this video, we are going to be solving quadratics, and this time we are going to be using something called the square root method. So there are a lot of different ways to solve quadratics, and we're going to learn about all of them. But the first method is to use the square root method. And this specifically applies to quadratics where I have a term with x squared and I don't have a term with x. So while we're at it, I kind of skipped ahead at this, but remember that a quadratic is a expression or an equation that has an x squared term. Okay. Sometimes you might have a quadratic expression that looks something like this. It might have an x squared and an x and a number out there. Okay? If that's the case, then this method would be of no use to us whatsoever. This method only works if we only have the squared term and the constant. Okay? So when I'm looking at this, we also don't use this for expressions, we use it for equations. So in order to solve, we would also need an equal sign. It'd have to be equal to something. But that wasn't really the point of this. The point was just to express which type of equation this could be used for. So quadratic equations of the form ax squared plus c equals 0 can be solved using the square root method. And again, what this means is there is no term that has just a plain old x. There's only an x squared term and a constant. Okay. The a stands for the coefficient of x squared, and the c is a constant that you are adding or subtracting. If this is the case, we can solve this using the square root property, where we isolate the x squared term, and then once we have x squared is equal to n, we can solve by taking the square root of both sides. We do this because obviously we have to do the opposite operation of whatever is in the equation, and the opposite of squared is taking the square root. So I'm going to go ahead and take the square root of both sides, and when I do that, on the left I get x by itself, and on the right side I have the square root of n. Okay, but, and again, n is just any number. It's not just the square root of n, it's actually going to be plus or minus the square root of n. So anytime you're solving an equation and you take the square root of both sides, you're actually going to have to include this plus or minus sign. And I'm going to explain this in a bit when I finish solving the actual problem, because I think it will make a lot more sense in the context of the problem. So now we can go ahead and move on to this example. So we have 3 steps to solving. First, we have to isolate x squared, then we take the square root of both sides, and then we simplify the radical. So these 3 steps are very similar to steps that we would use to solve any other equation as well. The first thing is to isolate the x squared term. This is basically the same thing we've always done, is essentially isolating the term that has x in it. So in order to do that in this example, I'm going to have to start by adding 64 to both sides. And when I do that, I'm going to be left with x squared is equal to 64. From here, x squared is isolated. So my next step is going to be to take the square root of both sides. So I'm going to go ahead and I'm going to say square root of the left side and square root of the right side. On the left side, I'm left with just x, because those two symbols, the radical symbol and the squared symbol, they cancel each other out. And on the right side, I have the square root of 64. When I evaluate the square root of 64, that comes out to 8. But like I said earlier, whenever I take the square root, I'm going to have to make my answer plus or minus that number. Now, this is the point where we get to talk about why that plus or minus is there. So when I look at this equation one step before, I had x squared is equal to 64. I think we can all agree that the answer x equals 8 would work when substituted back in. I can go back to this x squared, I can plug in the 8, and I can say, okay, does 8 squared equal 64? Yes, 8 squared is 64, so 64 equals 64, and that solution checks out. But let's think about this other option that I put, negative 8. Well, because this term is squared, the x is being squared, if I were to plug in a negative 8, what would happen? Well, I take negative 8 and square it. That means negative 8 times negative 8. And since a negative times a negative is a positive, when you square the negative version of a number, you actually always end up with the same positive answer. So negative 8 squared is the same as 8 squared. Negative 6 squared is the same as 6 squared. Negative 2 squared is the same as 2 squared. Any number and its opposite squared are both going to be the positive numbers. They're going to be the same as each other. So whether you plug a positive number back in for x or a negative value in for x, you will get the same result. So that is why anytime you are solving an equation and you have to take the square root of both sides, you're going to have to put in a plus or minus, because you could plug the negative version or the positive version in for x, and you would still get the correct answer. With that being said, let's try another problem. So looking at this one, we are once again going to start by isolating x. So there's a couple steps here, right? If I want to get x squared by itself, the first thing that I'm going to have to do is add 11 to both sides. After I do that, I'm left with 2x squared is equal to 32. And then from there, I'm going to go ahead and divide both sides by 2. And now we're at the part of the equation where I can take the square root of both sides. So when I do that, on the left side, remember, I'm left with just x. And on the right side, I have the square root of 16, which is 4. But I have to say plus or minus, because it could be either the positive or the negative version of this, right? 4 squared is 16, but negative 4 squared is also 16. Okay, now we're going to take it to another example. And again, I'm going to go through this first part relatively quickly because you know all I'm doing is isolating the x squared, and I think we all have a ton of practice doing this part already, sort of like solving any other equation. And then once I get to this part here, x squared is equal to 2, I'm going to go ahead and I'm going to take the square root of both sides. That leaves me with x is equal to plus or minus, the square root of 2. That's not actually going to be a whole number. That comes out to approximately like 1.4 in your calculator if you type it in. However, when it comes to these answers, we want to see exact answers. And if you type it in your calculator, you'll see that you have this really long decimal with like 8 places. We don't want to have that decimal represented, because even if you put all 8 digits that your calculator shows you, or however many digits it is, it's still not an exact answer because it's in infinite decimal. It continues on beyond what the calculator can display. So if you want to have an exact answer, we're actually going to leave this in radical form. So I know that's a little different than things you're used to. We're used to numbers just being, answers just being straight up numbers. And there is kind of this radical symbol here. So I know it's a little different, but this is actually going to be something really common when we start solving quadratics. So it is time to get used to seeing the square root sign in answers. And again, we are going to do that anytime that I don't have a perfect square. So essentially, when I take the square root, it wouldn't come out to a whole number. If it does come out to a whole number, you would still write that, because obviously we'd rather write like 2 than the square root of 4. We're going to look at another example here, and our answer is going to come out a little bit differently once again. So again, I'm just going to kind of speed through this first part real quick because I don't want the video to take too long. But as I go through and I isolate x squared, you'll notice that on the other side, that division doesn't come out perfectly. And again, because I said that we're going to be emphasizing having exact answers, I don't want you to type that in a calculator and get a repeating decimal. I want you guys to leave that as a fraction. And then after that, I want you guys to take the square root of both sides just like you would any other equation. And then we're left with x plus or minus. And again, if I type that in a calculator, it would come out to a weird decimal. So I'm just going to leave it like this. X is equal to plus or minus the square root of 16 over 81. But there is one thing special happening here. And if you look at both the numerator and denominator of this fraction, you may notice something. And that is that the numerator is a perfect square and the denominator is also a perfect square. So I can actually simplify this further. I'm going to rewrite this off to the side just so that I have a little bit more working space. But this is literally just what I had written down there before. One cool thing about radicals is that if I have a division or a multiplication under the radical symbol, I can actually break it apart into 2 pieces. So I can rewrite this as the square root of 16 over the square root of 81. And that is an equivalent expression to the one that you're seeing above. And from there, I can actually take the square root of the numerator and the denominator separately. So I just copy down the x equals plus or minus, and when I take the square root of 16, that leaves me with 4. And when I take the square root of 81, that leaves me with 9. So my answer ends up being x is equal to plus or minus 4/9. And I hope that you will agree with me in saying that this answer makes a lot more sense than had I just left it like this answer over here. Because the square root of 16 over 81, like, I don't know what that comes out to. That's not the type of number that really makes sense or has meaning in my head. But if I can simplify that down to a fraction, like 4/9, oh, I'm like, okay, this is a number. It's a little bit smaller than a half. Like, I have a little bit of context that helps me to make sense of that number. So we always want to have the type of answer that makes the most sense to us. So that's why we are going to continue simplifying as much as we can. And now we have yet another type of problem. So this one's going to come out differently yet again. So let me go ahead and start solving this one. Again, I'm starting by adding to both sides, and then I'll do a little division real quick. That leaves me with x squared is equal to 32. Once I have this, I'm at that situation again where I would take the square root of both sides. And that would leave me with x is equal to plus or minus the square root of 32. Now, at this point, you might be saying, oh, great, we're done. There's no fraction, so I'm not going to have to simplify anything. But if you're saying that, you would actually be incorrect. So there actually is a way to simplify this. And that is by simplifying this radical. Now, I just made a whole other video on simplifying radicals. So this should theoretically be a review from Algebra 1. So we should have some background knowledge on how to do this. If you don't, and this is too quick an explanation for you, feel free to go back to that other video to see more details on why this works, how it works, and everything. But I'm going to go through this relatively quickly. Basically, I'm going to split 32 up into its two factors. And there are different factors that would make up 32, which are numbers that multiply to 32. And I specifically want to pick two factors where one of them is a perfect square. And even more specifically, I want it to be the biggest perfect square that fits into 32. And in this case, that would happen to be 16. So I'm going to rewrite 32 as the product of 16 and 2. Okay. From here, just like I did in the last problem with the division, when I have a multiplication, I can split this into two separate radicals, and I can rewrite this as the square root of 16 times the square root of 2. And what that does for me is it gives me one square root of a perfect square. So I can actually evaluate the square root of 16, and I know that that comes out to 4. So in the end, x is actually equal to plus or minus 4 times the square root of 2. And that is my answer in its simplest form. Now again, I know that if you were unfamiliar with this concept of simplifying radicals prior to this moment right now, like that probably didn't make a ton of sense. But again, I don't want this to become an hour-long video, so I do have it split into two. And if you need more practice with that, please go to the other video and practice that separately, and then maybe come back to these examples and see if they make more sense next time. I'm also always happy to help you guys out with that concept if you need help with it. So send me an email if that is what you need. That being said, we're going to keep moving on and try another example though. So here we have 9x squared plus 3 equals 111. Again, I'm going to start by isolating the x squared term. So I'm going to subtract 3 from both sides to get rid of the positive 3. That will leave me with 9x squared is equal to 108. From this point, in order to get x squared by itself, I'm going to have to divide both sides by 9. And when I do that on the left, I'm left with x squared. And when I do that on the right, I'm left with 12. Now again, next step is to take the square root of both sides to isolate x. When I do that, I'm left with x is equal to plus or minus the square root of 12. Okay. From here, my next step to check is, can this radical be simplified? Can I simplify the square root of 12? Well, looking at 12, I'm thinking, what sets of numbers can multiply to 12? And are any of those factors perfect squares? So I happen to know that the way I can multiply by 12 is I can multiply 1 and 12. I could multiply 2 and 6. Neither of those help me. Those don't have perfect squares. But my other option would be to multiply 3 and 4. And if I multiply 3 and 4 to get 12, 4 is a perfect square, so that does in fact help me. So I'm going to come out over here, and I'm actually going to rewrite this as x equals plus or minus the square root of 4 times 3. Right, I'm writing the same expression, I'm just writing it in a new way. Instead of writing 12, I wrote 4 times 3. But since those are equivalent, I'm absolutely free to do this. From there, I'm going to continue, and I will split this into the two separate radicals so that I have the square root of 4 times the square root of 3. And then when I evaluate the square root of 4, I get 2. And my answer comes out to x is equal to plus or minus 2 times the square root of 3. So that is going to be it for this video today. Hopefully that was helpful. And again, if you do have any other questions about using the square root method, when to use it, how to simplify radicals, please go ahead and let me know so that we can work on it together.